Hi everyone, we will solve GATE 2015 Aerospace Engineering question number 56. Consider a 2D blunt body in an incompressible fluid stream. The flow is rotational and can be modeled as a linear combination of a uniform flow and a line force, which is called Rankine-Half body as shown below. Here this diagram is shown where this Rankine-Half body can be modeled as the combination of line force and uniform flow. Let S be the distance of the line force from the front stagnation point. S is the distance between stagnation point and line force. Let D be the upstream distance from the stagnation point to the stream-wise location labeled below SP, where the oncoming stream reaches 90% of its undisturbed velocity. This P point is such that here velocity is 90% of the undisturbed velocity and its distance from stagnation point is D. Then dy s equal to, we have to find ratio of D and S. So this problem is related to potential flow. To know more about potential flow, you can refer to this NPTEL video. So first we will see what is this Rankine half body. So Rankine half body is a semi-infinite body, and for flow past the semi-infinite body we can model as the combination of one line force and one uniform flow. Two or more incompressible rotational flow can be combined by superposition simply by adding their velocity field or potential or stream function field. Flow past a semi-infinite body is a combination of uniform flow and the force flow. So this is the combination of force flow and uniform flow. So this potential function will be potential of force flow and potential of uniform flow. So this is the potential of force flow, this is potential of uniform flow. In this one, we have taken origin at the source flow. Similarly, stream function we can get as the combination of these two, stream function of uniform flow and force flow. These are in Cartesian coordinate and these are in polar coordinate. U and V velocity also we can get directly by adding this velocity for the force and uniform flow, or we can directly take U equal to dou phi by dou x and V equal to dou phi by dou y. Then we will get this. So now we have to find where is the stagnation point. So at stagnation point, velocity U equal to 0 and V equal to 0. So in this formula, if we see that V equal to lambda upon 2x y upon x square plus y square. So this, for it to be 0, it is only possible when y equal to 0. So one thing we got, y equal to 0, and u equal to 0 means u will be lambda upon 2 pi x upon x square plus y square plus v infinity equal to 0. We already know y equal to 0, so it will become lambda upon 2 pi x equal to minus v infinity. So we will get x equal to minus lambda upon 2 pi v infinity. This is the location of stagnation point from this origin source. So this distance is minus k lambda upon 2 pi v infinity. So we have to use this in this problem. So now we'll solve our problem. So in the problem, it is given that this stagnation point position is distance is s, and at p velocity is 90% of free stream velocity, that is 0.9 v infinity. So before already we have found the what is the distance of stagnation point. So this minus s equal to this value minus lambda upon 2 pi b infinity. So we will get s equal to lambda upon 2 pi b infinity. This is the first equation. Now second condition is given at p. This velocity is 0.9 of v infinity. Here this y equal to 0 because it is on the same line of stagnation point. So at p y equal to 0. So it means v equal to 0. So only u will be 0.9 of v infinity, which is lambda upon 2 pi x upon x square plus y square plus v infinity. So here we already know it is v equal to y equal to 0. So we will put it here. So we will get 0.9 v infinity equal to lambda upon 2 pi x plus v infinity. So we will get minus k 0.1 v infinity equal to lambda upon 2 pi x. So x will be minus 10 lambda upon 2 pi v infinity. Here x is the location of point P from this origin. So this distance is minus d plus s. Minus d plus s. So our d plus s will be 10 lambda upon 2 pi v infinity. We have already seen this lambda upon 2 pi v infinity is s. So it will be equal to 10s. So d equal to 9s. So dys will be 9. So this dy is equal to 9 is our answer. Thank you.